Okay, gotcha. So what page did I give you guys last night, or last time? 115 and 116. I did. Okay, so I accidentally had you do what was supposed to be given tonight. So what we'll do is we will actually collect both on Wednesday because we don't have class tomorrow, right?
Why not?
It's testing day. Practice. So we have school, but we don't have actually this class itself. So. Or do we have this class? Is it like in the afternoon? Is it goofy? One of the days that we have some goofy.
It's next week.
That's next week we have the goofy?
Yeah.
Tomorrow is just no classes at all. It's just some sort of testing. Okay. So the page 115 and 116 that I gave you, we will make due on Wednesday. Because I accidentally gave you the wrong pages to do. I apologize. I did not mean to goof that up. But we'll make it all right.
Is that homework?
Well, that's what I had assigned, but I didn't. What I'm teaching today is actually what that homework was. Yeah.
Did you do the odds or everything?
I forget, what did we assign?
Odds.
Odds? Okay. No, so it'll be odds on this, but this will be for tonight. So we don't have necessarily homework to go over because let me teach the lecture on this and then I'll make the correct assignment. And then you'll have some time to work today in class on both so you can get caught up. Is that okay? Does anybody have old homework that they need to turn in that's prior to page 115, 116? If you have anything old, bring it on up and we'll put you in the book.
Thank you. Surely.
How you doing? Pretty good. All right. Okay, so does that make sense that I accidentally gave you the wrong assignment? And maybe some of you might have been able to do it, which is great, but I'll put another note up at the very end when we get through. Okay, so warm up, we're just going to multiply. So remember when we're multiplying these, you go outside to outside, inside to inside, and you wind up with x squared plus 4x minus 4x plus 16. Those cancel out. Oops, that should have been a minus 16 right there. Sorry about that. And so you get that. So this becomes one of those where we want you to start recognizing the difference of two squares. That's obviously the difference of two squares. This is going to be the same idea. Outside, outside, inside, inside. So you get 9x squared minus 5x plus 5x minus 25. Those cancel each other out. So you get 9x squared minus 25 for an answer. And then when you have just letters.
Wait, isn't that 3x minus 5? To simplify it?
So that should be 15 and 15.
Oh, wait, never mind, sorry.
Good. And this one's a squared plus ab minus b squared. And then the middle terms fall out, so you get a squared minus b squared. Okay, any questions on those? We've seen these before. Just kind of going back and talking about them a little bit. So that's called the difference of two squares. This, we have to recognize that I have this twice. So if I multiply this out, I wind up with x squared minus 4x plus 16. The middle terms don't fall out because they're not opposite signs, so you get this. And so that's called a perfect square trinomial. It means it factors into the exact same two binomials. Number 5 is done the same way. That's x squared minus 12x plus 36. Again, perfect square trinomial. And then the last one, I come up with 4x squared plus 6x plus 6x plus 9. Combine like terms. So again, we get perfect square trinomial, meaning if it's a perfect square trinomial, it does factor. It factors to the exact same two binomials when you factor it. Okay? Does that all make sense? You're okay with foiling or double distributing or whatever the words they want to use? You're okay? Yeah. Cool. All right. Can I move on? I'm going to start copying. Cool. All right, so we had two special cases. So there was the difference of two squares, and then there's the perfect square trinomials. And I don't expect you to always recognize perfect square trinomials. When you factor it, you happen to see it, and it happens, and it's like, hey, I have the same two binomials twice, which is great. Difference of two squares is something that pops up often in math, and it's just one of those that hopefully we see it enough that we get good at it, we can recognize it. The first term and the last term have to be perfect squares. Remember, if you have x squared or x to the fourth or x to the sixth, that is a perfect square. And then obviously your perfect square numbers being 1, 4, 9, 16, 25, 36, keeps going. Okay, so problem number 1, it's x squared minus 36. We want to factor it first, and then we want to set each of those binomials equal to 0. So let me ask you this, friends. Is x squared a perfect square? Yeah, because x times x is x squared. Is 36 a perfect square? Yeah, because 6 times 6 gives us 36. So this one will factor to x plus 6 and x minus 6. And then once we factor it, we're going to set each binomial equal to 0. And of course, most of you can do this in your head. I'm just showing the third or second or third steps, which a lot of times you can do it in your head pretty quickly. So you get a positive and a negative result for your answer. Then let's see, problem number 2. Kind of hard to solve something like this. You have 25x squared. I'm going to subtract 49y squared on both sides. Okay, now we have two variables in there, so we can't really both solve for x and y in this problem. So what we'll do is just factor it down. 25x squared is the same thing as 5x times 5x, and 49y squared is the same thing as 7y times 7y. So this factors to 5x plus 7y, 5x plus 7y, and 5x minus 7y. And I'd say for right now, I would just leave that as is. I mean, if you did solve for x, you're going to wind up getting a y on the other side. So I don't think it's 100% necessary to go much further than that. I think in that case, if you have both x and y, just factor what you can and leave it. Okay? All good? Everyone have a nice weekend? Yeah. Hope so. Hope so. All right, problem number 3. We want to factor it. And again, this, I will tell you, is a perfect square trinomial, but a lot of you might not recognize it as that, so we'll do our way. We multiply those, and we get a positive 49, but we have to realize it's a negative and negative. So the two numbers that multiply together that give me 49 that add together is 7 and 7. So then if you factor it, you're going to get x minus 7x minus 7x plus 49. And then remember, group it. Bring this sign down. And if you bring that sign down, it changes this sign. So we wind up with x minus 7 and x minus 7. And if you set that equal to 0, you get two answers. You get 7 and you get another x equals 7. Okay, so you have it happen, it crosses the x-axis twice at 7. Okay, it's called the double root. That's where in math you might start hearing a term in maybe next year in geometry or in Algebra 2. There's times that things bounce off the x-axis, and this is a bounce. Okay, there's a bounce, a wiggle, and a cross, and in Algebra 2 you'll definitely focus on the bounce, wiggle, and cross a lot more. Okay, problem number 4. It says, hint, greatest common factor. Well, does 6 go into itself? Yeah. Does 6 go into 60? I think so. Does 6 go into 150? I think so. I think it goes 25 times. So on this one, you could indeed factor a 6 out. You don't really worry about this. It's just a variable. We let it go. So then we just factor here. And that actually factors, just for sake of time, to x plus 5 equals 0. So that means my answers are x equals -5 and x equals -5. So again, this is a double root, and a double root, when you look at the graph, creates a bounce.
How does that look like?
Looks like this. Let's do it over here. It just bounces like that. Yeah.
Wait, so how do you know when to divide 6 by?
Oh, so I just was going by, they said they have a hint, so I was just like, I wonder if I can do that on everything, and I could.
And what if you can't find the numbers that you can? What if
Then
it doesn't?
you just factor out what you have. Like a normal factoring problem. Okay. What are we at on this? And so, then it says, how can you recognize the difference of squares pattern? Is if this is a perfect square, and you have a subtraction sign in the middle, and this is also a perfect square. Okay? So perfect squares, you know these as their numbers. But then you also have to recognize that x squared and x to the 4th and y squared and y to the 4th and y to the 6th and x to the 6th, and even if you raise to an even number, that means it's a perfect square as a variable, because if you take a number times or a letter times itself, you get squared. If you go x squared times x squared, x to the 4th, x to the 3rd times x to the 3rd is x to the 6th, and so on and so forth. Okay, so what I would like us to do, I'm going to give you a nice amount of time to do this. Again, it was kind of my error the other day. It was all my error the other day. So I'd like us to do page 113 and 114, and I want all of these ones done. Okay, that's just 16 problems. And then on page, this is what I assigned the other day, and I said odds on this one. Is that right? So I want to give you the rest of the period to work on both of those. Get as far as you can on them. Ask me questions if you have questions on it. But that's all I got. Is that okay? Huh? These both will be due on Wednesday. These are both due on Wednesday. So I'd like you to be working on this during class. If you happen to get them all done, that means you're pretty much solid for come Wednesday. We'll go from there. And then, hang on a sec. And then just notice on our board, I have tomorrow X'd out because we won't have class tomorrow, but we do have school. We have the testing. And then we have number 10, 11, and 12 to do. So we don't have any quizzes this week, which I know some of you might be all upset about that, but most of you be okay with it. So that's what I got planned. We good? What you got?
I wasn't ready. Can I have the?
Yeah, I'll run next door and get those notes for you. Cool. Let me stop that.